Hey guys,
Hello.
Hey,
good. So we're back.
yep. So yeah, that was
Sorry,
the.
so Rick, please.
Can you hear me?
Yes.
Okay.
Can you
Yeah.
share your notebook or
Oh,
whatever
sorry.
you were
Yeah.
sharing?
Yep. Let me do that. Where did that go? Oops.
So you'd said you use a couple of different language models and then kind of created the embeddings for the essays. Is
Yeah.
that what you said?
Yeah.
I see.
So
So,
each
and that's
essay,
where you were saying that the embeddings for Llama were like very large.
exactly. So this one's embedding is like 512 for dBERTA v3, and for like Llama, it's like 32,000. So you kind of run out of memory when you're trying to fit an LGBM on that. So you just use PCA and then kind of reduce that size, and then
Map that down.
yep, exactly. And then use LGB or any form of classifier that you want to do, then kind of classify that. And yeah, it works, but obviously I can't still get anywhere close to what the publicly do. The public high scoring one is also. But yeah,
then
there are
does the public
variations.
high scoring one use ensemble, or is he just using
It does use the ensemble of those classifiers, right? Like which we just saw, it uses this voting classifier. Basically, it's an ensemble of knife base, SGD, LGB, and CAT.
what is MNB?
Multinomial base.
Oh, I didn't.
So they use that.
Guys, may I ask
Sorry?
you one question?
Yes.
I have a question. These voting classifiers,
Sorry, 1 second.
do you know how to fine-tune them properly? Because you can have 1, 2, 3 models. You have 2, 3, 4 models. You can also establish weights for the models. Do you know how to get the best combination? Or what is the trick? What is the trick for this? Is there any trick for fine-tuning a voting classifier?
For me, that is the biggest trick is to find a very good cross-validation set that kind of matches your leaderboard. Ability to do that, I think, is like the biggest part for me because I still can't, do that. So idea is you should be able to create a test set which is able to mimic your leaderboard score, or in real world scenario, whatever your real world data is going to be. And then you kind of run a bunch of, I don't know, let's say hyperparameter optimizations like Optuna or something, where you kind of iterate over these weights and then kind of see which gives you your best.
Weights,
Yes,
yeah.
exactly. So yeah, that is the essence. And I think if you search around in Kaggle, you'll see that idea shared around a bit. There are like some snippets of code. I haven't yet reached that part. But if I do, I'll share that with you because that's something I'm also very interested in. But the idea is that like you create a good enough validation set that you can trust, and then you run this hyperparameter optimizations on different.
Yeah, because one of the things I saw, because I make a test with one notebook, is that you can set up a threshold for the classification, so you can improve your false positive, false negative, let's say, balance somehow, and then you can run after you do the voting classifier. You make the first voting classifier run, then you check the threshold with the model, and then you come back and then you change the threshold, and then you run it again. That's one of the approaches I saw that could be useful. In my case, for example, the test that I tried, it didn't work. It just remains the same, false positive, false negatives. But yeah, I wanted to know,
Okay.
maybe other opinions. Yeah, thank you.
Okay. Yeah. So talking about the false positive and false negative, the other idea that I've seen is there are some results that are going to be easy. I mean, some of the tests that you are running on, the model should be able to classify that with pretty high accuracy. So the other approach that I have seen is basically, in this case, it's a classifier, right? So you want to say that it's 0 or 1. So let's say anything above 80%, again, you have to choose this number, this threshold, and say that, okay, anything above 80, I'm really confident, and this is going to be 1. Anything below 0, I mean, below 20 is going to be 0. So I'm going to be confident with that. And that middle range, you could go back and run other models. And I don't know, like maybe that can help. Maybe there are some specific models that you could go, which would kind of help with these harder problems. So that is another approach. Yeah, again, it just takes so much time to try these ideas out. But yeah, those are kind of theoretical things that I know. Talking about that, I tried something which I was waiting to try actually from the last competition, and that was the idea of pseudo labeling, where you have a very minimal set of ground truth labeled data, but there is always going to be way more unlabeled data. So my idea was I trained a support vector machine on this task, and I made a submission. So I got, let's say, something around 70%. Then my idea was to use the test set, make the submission on that, calculate whatever the scores were. Anything above 80% or below this 20%, which I was confident with, I used that back into my training, retrained my SVM. So I had my original train plus this confidence below 20, but above 80 data added onto that, and then retrained my SVM and then made a submission again. And that bumped my score up, but that's pretty much where I reached with my experiment. I couldn't kind of validate some more. So yeah, if someone is interested on that approach, that was something again. I mean, but you're bound to overfit in that scenario. You're kind of using your test data there again. So that was one more thing that I got to try.
Yeah, I think that someone mentioned in one of these notebooks approaches that overfitting the model just bump the score to the top, or let's say just to get better scoring.
Yeah, because I think the metric here is AUC, right? So yeah,
it's AUC.
Yeah, exactly. So that should help in that way. Yeah. Yeah, that's pretty much it that at least I have on my side that I can think of on this LLM competition.
Interesting.
Yeah, it's very interesting. Unfortunately, it's going to end soon. And yeah, there are quirks with the data and blah, blah, blah. So the next iteration probably will be interesting to see what happens from here. But yeah, they have an efficiency measure also. So that is something that they care about. Yeah, any other questions or anything else regarding this?
That's fascinating. How many more? Just 10 more days to go.
Yeah, just 10 more days, I think. Yeah. Oops. Where is that? Yeah, just 9 more days. And let's look at how the leaderboard looks like.
Yeah, I think, as we discussed, if everybody can kind of look at what we posted, as well as spend a little more time on that and see whether any other competitions show up. I haven't seen anything else show up. Can you quickly check that?
Yeah, I don't think anything else has at least.
It's shown up. So this one does seem interesting, the HMS one.
Yeah, the HMS one, yes.
So,
yeah, the Benefit one, I don't, yeah, again, like that's also just like 18 days, and that's very similar to the last time series competition that we all did. This one is just that you're predicting what the power consumptions are going to be like. So yeah,
this is not ongoing one, right? It would end when it ends.
Oh, this ends. That's what I'm saying. This ends in just like 18 days. So this was something else.
Right, but it's not unlike the Optiver one. This is.
Oh yeah. Like, I don't think it takes that long.
Not an ongoing thing into the future.
I don't remember what they say, but I think it is not an ongoing one.
And are you also using like Tabnet and LGBM for this?
I haven't got to Tabnet, All my variations have been LGBMs, this voting classifiers, voting regressors. That was something kind of new to me. Like I had never seen that built in. So I used to always do my own sampling by myself. So that was interesting to kind of see, and there is something built in there. The other interesting things
Wait,
were
sorry, in which one are you saying built in?
like the voting classifier and the voting
Ah,
regressor,
okay.
something,
Yeah,
yeah.
yeah.
So you can use that if you want. I've been struggling with building my models offline and uploading them onto Kaggle because then it never works. So I have some issues with versions, or I don't know what the problem with LGPM stuff is. What else
Hmm.
have I tried on this?
So you mean doing it on Colab or offline and then
Exactly.
uploading as a data set?
Yes. With a lot of
Ah,
trial and effort, I managed to do it with LGBs. But like, for example, I can't still, like, if I train the whole voting classifier outside and try to bring that in, if I either pickle it
mhm.
or use joblib, I still can't load it and successfully run
So,
it.
by the way, have you tried what Steve had suggested, which is if you have a notebook that you could just, and then you can just like import code, run the notebook on Kaggle, and then import the notebook into your
True,
ensembling notebook.
that makes sense, but the problem is I still have to run the model. The model has to be trained, and that is still GPU hours, right? Not my GPU hours, but still it takes time. But if I can load a pre-trained model, then it's just running inference. There's no training aspect there at all. That is the
Correct.
reason.
So, but I'm saying you don't. You're unable to bring it in as a data, a pre-trained model as a data set.
Yeah. So I train my
Ah,
model on Colab, let's say. I download that, pickle it, then I upload that as a data set on Kaggle, and then just try to read
right.
that and infer. But yeah, that does not, for some reason, I still haven't got that working. It errors
Ah,
out. It
that's
can't identify. So I'm not 100% sure.
you
Like,
cannot read it, or
no. When it reads it, it reads it like that, but then it says like something is missing. And especially for LGBs, I found out that you need to kind of store it as a .txt and then bring in that in, and then it works. Like if
right.
you do joblib or pickle, it does not work. So I don't know if there
Oh,
are
that
those
may
kind
be.
of nuances with cat boost and other things like that. Or I
Yeah,
may
it might be a pickle
stupid.
problem.
Yeah, that's what, yeah, it could be. So, I mean,
But
learning that
the
I think is important because you can save so much time. You don't have to wait like for 6 hours, 7 hours for something, right? Like, especially like once you find like a base model that you know is working and you want to iterate over that by ensembling, then you know these 6 hours will give you a result of like whatever 96%. Just that
right,
additional that you want to check. So,
right.
yeah. So,
That's
anyway.
strange because it says I haven't tried recently with LGBM models, but LGBM models typically also are very fairly small, right? They're not very
No, they're not
gigabyte and
large.
stuff.
It's not, the size is not the issue. Yeah, it's kind of like, for example, the voting classifier, when I pulled it in, it said that all the models need to be trained. So that means like whatever I trained there, the parameters somehow didn't come back in when I pickled it or joblib used joblib. So I'm not 100% sure if I was missing something. I haven't really investigated, but yeah.
Ah, okay, okay.
LGB is the only one which I succeeded with, and that the issue was you need to bring in like a .txt and then kind of use that.
I see.
So
Because I mean, I haven't done it frankly with LGBM models, but I know I've done it and Steve has done it with multiple other things
yeah,
and
the
haven't
debertas and all that
encountered.
work. There must be
Right.
some particular small nuance with this that is, I mean, like I was reading someone else's solution where they specifically talk of this, where they train offline and then bring the model in. So it's surely doable, or it could be just like a version mismatch on my end. What I am using on Collab or what I'm using on Jarvis, the versions of like scikit-learn and all that is not matching up exactly. So there is some error there. So
I
yeah, there are like a few things to still check before, yeah, rule that out completely. But yeah, that's something I don't know. It took a lot of time for me to kind of make
see.
progress. This one, yeah, that's pretty much it. Like, there's really nothing to talk about this competition other than it's very similar to that. You're predicting power consumptions.
I guess the challenge is figuring out what features matters and what combinations and what
Exactly.
kind of like the windowing back,
Yeah, the lag.
the size of the windowing back. Yeah, the lag.
So feature engineering is the main thing over here, obviously, like,
Right.
and then throwing that into one of those models to kind of predict stuff. And yeah, like one of the interesting things that I saw in the notebooks was like if you look at where is that? Oh, not this. You can see how this oops uh the numbers are like this is the target that you're trying to predict, and you can kind of see what the range looks like. It starts from like 0 and then it goes up like really high. And if you
So
start
the range is very vast.
yeah, but if you actually start looking at stuff, you start realizing this is consumption column, and like 1 0 basically is like if you're consuming, and then 1 is like if you're producing. So if you just do a split on 0 and 1 and like build two different models on 0 and 1, you kind of already see a boost. And so it kind of helps in the range of things being set.
By the way,
So
the one thing I took away from Optiver, I don't know whether you're doing this in the current model that Steve did, which, like Steve also did toward the end of the competition, and I was like, which was very smart, and I was like, man, that makes a lot of sense, but wasn't something that came to mind initially is that right, one, that you can train or tune previously trained LGBM models. That's like with you can provide a starting point to LGBM models, which can serve as your pre-trained models, and then fine tune on the new data that you're seeing.
Yeah.
And the second thing which he did, which I thought was, that was itself interesting, that LGBM models can be fine tuned this way. But the second thing which he did towards the end of the competition, which I thought was really smart and kind of like, which we had thought of it earlier kind of thing, is the fact that you can, so, he originally had trained it when he was fine tuning the model, he was creating a new training data set of all of the data until that point, and then any new data that comes in, and fine tuning the model on that. But what you could do is do that on the fly. That is, as each day comes in, you can kind of incrementally add the day and fine tune. But of course, now that I'm thinking about it, in this case, because it is all kind of fixed data set, it doesn't really matter.
Yeah, I don't think anything is coming in. Yeah. Yeah, actually, since you said that, I'm curious. Like, see, the annoying thing about pre-training outside and bringing an LGBM model is you cannot add new features at that point of time. At least I don't know how you can add new features because you have trained your model on a certain set of features.
You can. By the way, I found out that I tried that and it actually works, but it doesn't give good results. Or what I should say is it's not guaranteed to give you new results. It can utilize features that it has not seen in training.
No, but that's a different story. That's what I'm trying to say. I know you can drop columns when you're making inference, but what I'm trying to say is like if you train on 100 columns, you bring that LGBM in, and now let us say I discover 10 new features. Now, in the fine-tuning process, can I add these 10 new columns onto my pre-trained 100-column LGBM and then retrain?
Yes.
So I don't have to waste retraining my 100-column model again.
Yes.
That is possible?
I actually did it in Optiver. Yes.
Oh, nice.
I actually did it in Optiver, but here's the flaw. The flaw was it gave me worse results.
I see. Ah, okay. That kind of makes
sense.
So
it's not guaranteed to give you, and when I poke around, it's not guaranteed to give you better results, but you can.
Sorry, go ahead. My Siri decided to talk all of a sudden.
Yeah, no, you can do that. So what I was trying to do initially was use features that I had not trained Because and I'm talking from memory, so my exact feature. So for example, there was like this new retrieved something that was only available in the new data that is provided in Optiver, right? So I was trying to use that feature along with whatever I already had in my pre-trained model, because that will only be visible in the new data. So I started with the pre-trained model, and then there is some flag, I think, that you have to set which says, hey, I'm going to give you new data. And the LGBM model is smart enough to see whether the new feature that it sees is helping it to split differently now.
I see.
Or differently. But what I found was that it cannot, there's no guarantee that it will give you better results. It did give me worse results, but it worked. Meaning it didn't choke. It did give me, a result.
Yeah, if you find that piece of code, can you share that with me? I'm curious to see, like, what.
Sure. I'm traveling over the next 2-3 days, but middle of next week or something, I'll look at
for the future
it. But I did run a notebook where I set it up to use new data that showed up.
So there is a column which basically says if there is a size mismatch, it will error out, right? It will say like you had 100 columns in training, but you have 101 columns in test right now. So there is a flag which you can set, which will basically drop that extra column. I know that is possible. So it won't choke.
Yeah, no, in this case, I did the opposite, meaning it wasn't dropping, it was actually adding.
It was including that.
And it was
nice.
Correct. Okay. And using that in what it was predicting.
Sounds good. Okay, cool. I'd like to check that out. I am curious. Yeah, but like as we were talking, I was thinking, yeah, probably that is still not the best case scenario. Like if you know if that feature does help, you rather use that for the full training than kind of squeeze that in at the end.
Yeah. And that's where I found out that, when I ran it, it used the new feature, but the results were poorer than when I did.
I see. Okay. Cool. Yeah. So awesome. So next week, I think, yeah, like I think this the HMS one is really nice, and I just saw like now that Chris Diot is also taking part, and he's already shared a notebook. So
he has some postings, and I saw some interaction between him and the other guy who did the I forget now that who did some EVA in stuff. This overlapping versus non-overlapping is the thing that's to me interesting, because also to figure out, because multiple spectrograms come from one, because the EEG is for 10 minutes, the spectrograms are 50 seconds, and the 50 seconds obviously can start and end at any point, so there will be a lot of overlapping 50 seconds. And the test data doesn't have that overlap. It's just for one patient, 150-second thing, if I recall correctly, and then whatever the experts have classified the probability of those 6 features. So the interesting thing is, how do you take the training data and create data which resembles the test data for your model to train on? Yeah, see, this is what I was saying, right? Like, is there any way to use the EEG features versus the spectrogram features? Because the spectrogram is the only thing he's saying that it's using right now, from what I read.
Wait, so this is the train.
Right. So the train provides all the metadata associated with the EEG, right? So for example, I'm sure Steve can explain more of it, but if you just go to the left and I can just rattle off what I know.
This is what from.
So the EG ID is the overall 10-minute EG unique to every EG, right?
Okay.
And then the sub ID gives, let me go back to and then the EG sub ID is for a sub portion of the EG, right? Oh, the 50 seconds corresponding to the spectrogram. Then the EEG label offset is the one that gives you the offset from the 0th point.
Okay.
So this, for the same EEG, like the offset from the starting point, right? So it's the offset in seconds. Then the spectrogram has the similar kind of thing, right? The spectrogram has a unique ID, and then the spectrogram sub gives, again, a subset of that. And the spectrogram label is the one which gives the label corresponding, of the 6, what is the label?
Wait.
And label ID, I haven't really found it's unique to each label, I guess. I haven't really understood
label
that.
offset seconds. Okay.
Sorry?
This is label offset seconds. So this is
No, that of the spectrogram, it's just the label of the offset of the spectrogram as opposed to the EG.
Right. So this is the same thing. It's a second still.
Right.
Yeah.
But it's an offset in seconds of the spectrogram. See, because the EG is of a 10 minutes, and then the spectrograms of 50 seconds, and there's offset of, and this is the thing I have to understand. I think Steve provides some
there's the same
plots which illustrate that in his analysis, which I haven't gone through. But the spectrogram offset is the offset within a 50 seconds. The offset of the spectrogram within an EG is the offset of the spectrogram starting point from the EG 0th point.
Okay.
Because the EG is of 10 minutes, the spectrogram is a 50-second slice within the 10 minutes. So the spectrogram would be offset from the EEG starting point, which is 0, right? Because whenever you start the 50-second window. And then within the spectrogram, there's another offset.
Wait, so both of them are basically the same numbers though right now? Like 6, 8, 24, 26, 30, 36, 40.
Yeah.
So
0, 2 and stuff.
Offset makes sense. Yeah, I need to look at, okay, what this one is. Okay, this one is interesting. Spectrogram label offset. Okay, cool. Label ID, we said.
Yeah, I don't understand the label ID. There's just an ID for each label that's given, I assume. The patient ID is, obvious of which patient. And if the patient doesn't change, if it's the same 10-minute spectrogram, it continues. Then the expert consensus is for the label of the spectrogram, and there are 6 classes, right? Like I mentioned, Caesar, LRDA, GRDA, and then some LDA or LPD and GPD, I think. So GPD and LPD and GRDA and LRDA are 4, and Caesar is 5, and the other is 6.
Right, so
6 classes.
Yeah.
Right, and then the votes are, how many votes are there of the experts for each of those in each of the classes.
Okay.
So each expert and the number of experts for each spectrogram varies, I believe. And those experts vote on what it is, right? And some of them differ on what it is. And the number of votes in each of the 6 classes is what is given in the Caesar vote.
Okay.
Or given in each of the underlying class name _ vote. Right? So it could be, for example, one guy says it's an LRDA _ vote, and another guy could say it's a GRDA _ vote for the same spectrogram.
Right. Now, where does the spectrogram ID match with train spectrogram? Oh, okay, I see. So this basically should be one of these Parquet files, is it?
Yeah. So those are the spectrogram posts. You can look at it In
Okay.
fact, if you want to look at the details, then it's there in the PDF files that are attached. But if you want to just glance at what a spectrogram looks like, then it's there in the, if you go up to the, I think just the basic,
But that is just the
post.
image.
Yeah, this is left is spectrogram, right is EEG.
Right, but this is this provided for every patient? No, right? This is
Yeah, it is, right?
oh
It
really?
is.
Where is
Yeah.
that?
What do you mean? It's there, it's linked to the train.csv, right? Which gives you the patient and the information of
So
what
wait,
spectrogram it
this
is.
says only example figures, right? There are just 20 of these.
Yeah, but that is just the examples, right? So that's where I was saying that the example figures are like, you can look at it in great detail. Like if you
Right.
look at, but the actual data is in the train spectrogram and
Correct.
train EEG.
So this Parquet file will
Parquet
just
file.
be like a tabular data, right? So it's not going to be an image, right? Please. So that's why I was under the impression that it's not image classification in that sense.
Oh, maybe then I'm.
Actually, didn't Steve share his notebook?
Yeah, and he shows.
He does put in a Parquet somewhere.
Oh, it gives you whatever these.
Right.
I
So
guess it reduces it to these tabular values.
Right.
So it's given, I guess the thing I was missing is the spectrogram and the EG are converted to tables of these FP1, FP, whatever location values.
So I don't know, like image as
so it's not image.
Yeah.
You're right. It's not image. Then it's more
tabular and time series.
Yeah.
I think that was my impression of this.
Kind of.
And if you look at the data, it was also only 24 gigs. So yeah, this one looks really interesting. I think, yeah. I'm convinced to join
because
this.
there's also a lot of data processing that you'll need to go through because it's like, so if you keep going down, the thing I was saying was if you keep going down, see, this is where, so stop there, and if you go up a little bit more, up, even more, little bit further up. Yeah, see, that's where I haven't gone through this notebook, but I'm assuming from what little I know, it's the fact that you have these slices is what is the things that matter because those are the correlations to right the where see he's saying so it represents the time period from 0 to 50 or from 0 to 50 times 200 is 10,000 samples and is shown in the FP1 plot. Stuff. So you kind of see the 50-second slices that the train CSV corresponds to some portion of this.
Interesting. Okay. Yeah, cool. I need to look at this. Yeah.
Steve? So there's a lot of data understanding that needs to happen.
Right.
In, thing before even understanding what the hell we are doing. So I haven't gotten around to that part yet. But you're right, it's not image classification that much is certainly. It's more tabular data corresponding to times that have to be sliced and then put in their appropriate places corresponding, and then based on that you have to kind of predict.
Yeah.
So it's a lot of these LGBM type of things. Then I would imagine.
Yeah. So I think is it fair to say next week we should all be kind of looking at the HMS stuff, or
Yeah. Yeah.
right? Okay.
Yeah, I think that'd be good. Yep. That would be a good thing for, having kind of going through EDA of the HMS and even kind of understanding what it is that we are expected to do, or what kind of approach to even just getting a good understanding of the problem set. I think good thing to work on.
Yeah, sounds good.
Okay, thanks, Rickle, for kicking off the Google Meet. At least salvage the complete disaster.
Yeah, sure.
Otherwise, so, and thankfully we are back too. So it was some problem with Zoom and or stuff which caused all these issues. Hopefully, which we won't have next week.
Sounds good.
Knock on wood. Okay, thanks everybody for joining. See you all next week.
See you guys next week.
Thanks, everyone. Take care.
Bye.
Bye bye.